In this video here, we're going to take a look at tilting. So when a rigid body is on the point of tilting about a point, the normal reaction at any other support is 0. So really that is the key point here, right? Just remember, as we've just said here, when a rigid body is on the point of tilting about a point, normal reaction at any other support is 0. So just make a note of this point here, right? Other than that though, we don't need too much more here. Let's just take a look then at a practice question here. So let's have a go then at this one practice question here for tilting. So for this question then we have a uniform rod AB of length 6 meters and mass 10 kilograms, which is resting in a horizontal position on two supports labeled as C and D here. We're told that AC is equal to 1.5 meters and AD is equal to 5 meters. We're then told that a particle of mass m kilograms is placed on the rod at B. We're told that the rod is about to tilt about D, and the question wants us to find the value of m here. So just as we saw in the previous video, right, for the practice question in that video, so that was based on the center of mass, we don't have a diagram again for this question here. So just as we did in the previous video and for the previous practice question here, we're going to start by drawing our own diagram, okay? So let's say then that this is my uniform rod here, AB. Clearly that should just be a straight line. It's not perfect, but you get the idea. We've got AB here. Now, this is a uniform rod, so we know that the center of mass acts at the midpoint here. So let's just say that this is here then, like so. And it has a mass of 10 kilograms. That's going to be 10g there, like so. We do also have two supports here labeled as C and D. So let's say then that this here is C. And let's say then that this is D. Okay, so this is C and this is D here. Okay. We're also given these two distances. So we know that the distance of AC here is 1.5 meters. So from A to C then, this is 1.5 meters. And we're also told that from A to D then, that's 5 meters. So if this distance here is 1.5 meters, that means that this distance then must be 3.5 meters, right? Like so. We will also have reactions then at these two supports. So I've got the reaction at C, which I'll label as R subscript C then to represent the reaction at C. And we'll also have a reaction at D, okay, which I'll label in a similar fashion. So R subscript D here, like so. So the center of mass here acts at the midpoint, right? So that's 3 meters along because the rod has a length of 6 meters. So this is 3 meters along. So if this is 1.5, that means that this distance here must also be 1.5, right? Like so. And then this distance here must be 2 meters. Okay. Like so there. So we're also told then that a particle of mass m kilograms is placed on the rod at B. So at B here, a particle is added. Okay. And it has a mass of m kilograms. That's going to be mg here acting downwards. Okay. So looking at our diagram here, are we missing anything? Well, we can work out this distance here. So this distance here then, well, from A to D, that's 5 meters. So this distance here then must be 1 meter, right? And I think at this point here then, we do now have everything that we need to answer this question. So before we perform any calculations or anything like that here, let's just make a note then about this line here. So this tells us then that the rod is about to tilt about D. And that's important because if the rod is tilting about D, then the reaction at this support here, C, will be equal to 0. And in that case, then we can simply ignore the support C. Let's just make a note of that here. If it's tilting about D, so tilting about D here, then in that case, the reaction at the support C will be equal to 0. And in that case, then we can just simply ignore the support C. So feel free to kind of remove it from your diagram. You could just kind of scribble over it. Either's fine, like so. Just removing that from our diagram there. So now what we're going to do here is take moments about D. If we take moments about D here then, Nice and straightforward, right? What we need then is the clockwise and the anti-clockwise moments. So for the clockwise moments here, what would we get? So which force then would produce the clockwise moment here? So imagine we hold our finger at D, right? That would be this force here. So if we push downwards, the rod would go clockwise. Okay. So the magnitude of my force here would be mg. We times it by the perpendicular distance, which is 1. We get mg times by 1 there. Nice and straightforward. So that's the single clockwise moment here, right? There's no more clockwise moments here acting on this body. And now for the anti-clockwise moment here, that would be this single force here then of 10g. So the magnitude of the force is 10g times that by the perpendicular distance, which in this case is 2, right? If we're taking moments about d. So 10g times by 2, like so. So we now equate clockwise moments and anti-clockwise moments. So equating those here, so clockwise is equal to anti-clockwise here. And in that case, what do we get here? So mg times by 1 is simply mg, right? Nice and straightforward. And then 10g times by 2 would give us 20g here. Now we want to solve and find the value of m here, right? That's all this question asks for, to find the value of m. So we just want m here, right? Divide both sides by g. Nice and straightforward then. What we find here, oops, try again. Therefore, there we go. M is equal to 20. Okay. So that would be 20 kilograms there. Okay. And there we have it. So nice and straightforward. That gives us the solution there to our one practice question here for tilting. And that brings the end then of this video here on tilting.